Hey everyone, this is the episode 43 of Take It Easy. 43. Hello, James.
Hi, I'm James. I'm the CEO and co-founder at Ionetic. We're developing better battery technology for low-volume car companies and low-volume automotive companies so that they can actually afford to electrify. Because one of the main issues right now is the solutions for battery packs are either not very good technologically or really, really expensive, which is causing a lot of the automotive companies to delay their electrification launch or in some cases, not even start yet. And with that 2030 combustion ban in the UK and the 2035 ban in the EU looming, it's obviously really important that we really accelerate electrification, especially to get to net zero as soon as possible. So that's what we do. We create custom tailored battery packs that are more cost effective so that if you're a low volume car company, you can get your vehicle on the road sooner and make that vehicle better.
Okay. I have to ask, first of all, before we get to the actual, discussion about the business and any technical stuff, what got you into this business? And obviously, you're pretty young, so you must have been very, very interested in this early on.
I mean, I've certainly always been a big car nerd. You know, I was the kind of kid who would try and like name every single car as it went past. And yeah, I've always been a big car guy. I used to watch Top Gear religiously and discuss it in school the next day. And then went to university, did mechanical engineering, as sort of to that end, and then ended up doing a lot of my undergraduate work on battery packs.
Okay.
So my third year group project during my undergrad and my master's thesis were both on battery packs, on the design, on the simulation, and on the testing of those battery packs. And then I got hired immediately out of university to become a battery pack researcher at Imperial College London, where I did my undergrad.
Okay.
And in that role, I spent a lot of time telling car companies how to make their EVs better, and looking at fleet data and looking at simulation and looking at charging and all sorts of different things. And then left that role at Imperial to start Ionetic. And in speaking to all these different car companies, we realized they all really had this same issue, and that's how we ended up here.
Okay. I'm always fascinated about the business journeys. Like as a semi, I shouldn't say failed, but like a tech, trying to be tech entrepreneur. I'm 45 almost now, and I've been doing this since I was like tech stuff since I was like 19 or even earlier. And I've been involved in sorts of startups. I'm always curious how people start and what makes them, rather than have a cushy job, somewhere, and just be your average, employee, and kind of check out at 5 o'clock and not care. What makes you? What made you decide to actually? Oh, I'll just have a business doing battery packs.
Yeah, I think. Yeah, I still sometimes get asked that. Like why not just go work for another company and have a good salary and way less stress. But I think for me, it boils down to sort of impact, I guess.
Okay.
I see this problem that exists. No one else really seems to be trying to solve it in any meaningful way. So I sort of feel obligated, right? Like we've got this big climate emergency that's happening, and there are lots of problems I have absolutely no idea how to solve, but I know this piece, I know how to solve this, and I know it'll be beneficial for the environment. So that's why I'm doing it.
Okay, so you basically saw firsthand that businesses are struggling to bring batteries to market because it costs loads of money, let's be honest. And never mind the production of the actual cells, but putting it all together and making sure that it's robust and it's not going to fall down on Earth as you're driving over cobbly road somewhere in, I don't know, can't name a city, but whatever, in Cambridge, say. Okay. And obviously you've had experience with EVs, so you're pretty, you know a lot of things about EVs, right? I presume.
I'd like to think so. Yeah.
The question is, I had a brief look at your website as you do. Who are you offering it to? Is it big OEMs, small OEMs? Your mums and pups, a guy that or lady that does like a car, an EV conversion, or are you trying to appeal to all of them? And how are you able to make what is, I don't want to know obviously any secret sauces because I'm sure you can't say that to us, but how can you provide a low volume and low cost at the same time? Because obviously those are like opposites for most people.
Yeah. So we're really targeting the lower volume market, sort of the niche vehicle market, looking at things like buses and commercial vehicles, emergency services, delivery vans, but then also looking at luxury vehicles. I don't want to name specific brands, but there's SUVs there, there's saloons or sports cars. So if you basically make less than sort of 20,000 of a vehicle, that's sort of really where we're targeting. And the cost component comes in on two sides. It comes in on the cost of the development, so the cost of developing this the tailored battery pack, but then it comes in also on the unit cost. So on the development side, we're significantly cheaper because we have found a way to make developing battery packs way more cost effective by using our battery pack platform and also by vertically integrating battery packs. So by doing the design, the test, and the manufacturing of battery packs. What that allows us to do is make that development cost up to 90% cheaper compared to other potential options that you would go with. Then on the unit cost, that's where it's a slightly more complicated conversation. So it won't come as a surprise to anyone. We won't be as cheap as what VW Group are producing batteries for. It is because it's an economies of scale game. But what we do find is that we can get low volume car companies into cheaper battery packs in the unit cost because we're creating this platform, or we've created this platform. When we go into manufacturing of these products, we're using really high throughput manufacturing lines that are really flexible, that are designed for the platform. So you can send down our battery pack production lines when they come online, the pack for a car, and then the pack for a bus, and then the pack for an SUV. So you can get really high asset utilization on this, and you can actually make the unit cost to that low volume car company cheaper than it would otherwise be.
Okay. So obviously there is a module component to it. There is a point at which you're not flexible enough to offer something that's super tailored for, I don't know, somebody wanted to convert. I'm gonna get a ridiculous example: a tank into an EV, and has like shapes at the bottom that are not exactly flat. You wouldn't be able to serve that, but a car or a van is fine.
So we don't do sort of a modular design at Ionetic, because what modular means to us and what we see in the market is that basically means you've got like a big block of batteries, and you just connect loads of these blocks together in some way or another to build the full pack. And we think that's a mistake because you're really sacrificing a lot about your design variability by making it modular. Things like width, length, voltage, and energy are all interdependent variables. So if you increase voltage, you probably increase length, for example. So those things are all tied. So what we do is we take what we call a cellular approach. So our smallest building block for our platform is the cell. And then we make our modules as wide or as thin or as long or as short as makes the most sense for your application. So hypothetically, we could convert a tank. If someone came to us and said, we want to build 50 tanks and we want to make them EV. I'm sure the Ministry of Defense might have something to say about it, but hypothetically, it's technologically possible to do with our tent.
Yeah. I'm going to now think about how efficient would a tank be, but never mind.
It'd be horrendously inefficient. I'm not recommending anyone does this, but it is possible.
It was a silly example, but yeah. So speaking of the configuration, then if a cell is like the building block for you, because I was wondering how you break things down. Some people might have modules that are a certain size or a couple of types of modules, and then you kind of fit it together like a Lego puzzle, depending on how how the pack needs to be configured for the customer, the voltage, like you said. That actually leads us to another example, but I don't want to ask you too many questions at the same time. But but firstly, actually, let's go there with the voltages. So obviously, you mentioned that the pack would have to be longer for the higher voltages, and I think the EVs so far, well, most of them anyway, have been 400 volts based. But obviously, there's a trade-off between the size of the pack and the charging speed, and everyone wants their packs to charge or the cars to charge faster, which is understandable. And for that, obviously, we need just higher voltages because that's like the easiest. The V in the A times V is easier to deliver via the same cable. How are you flexible on the configuration of the pack, like in terms of like how many cells are parallel, how many cells are in string and all that sort of jazz? There's a term for it, technical term, I can't remember what it is, but the
parallel configuration.
Are you fully flexible on that, or is that all locked in?
Yeah, you can have whatever you want, basically. So we use our software tool internally. So you come to me with your requirements for energy and mass and voltage, and our software will say, this is the best configuration for you. This is how many modules you should have. It's how many series, how many parallel. That exactly works for your solution. And there are trade-offs to be made between sort of a 400 volt or a 7 or 8 or 900 volt architecture. Mainly to do with high voltage isolation, right? To make sure you're protecting it from short circuit. But in general, we tend to say that higher voltage is better because it means the vehicle's more efficient. It means you can charge faster in theory, because you've got that V equals IR drop, right? So if you can increase the voltage, you can drop the current, and then you can have less power loss. So you're overall more efficient. More of the energy out of the battery is going towards turning the wheels. And equally in the converse, when you plug in the charger, more of the charging is going into the batteries and not into cooling the batteries. So in general, we say higher voltage is better.
Okay. Yeah, I would have to agree with that. I think there's there's a trade-off, but also it costs more money to have all the safety equipment in place the higher voltages you go. And I had somebody from a charger manufacturer on the podcast about 2 years ago, and he mentioned to me that I think that the limit that he sees in the industry is about 1 kilovolt, because everything gets way more expensive above that. Would you agree with that, or do you ever see us exceeding that?
I mean, I think a lot of current off-the-shelf electronics parts are designed for 1,000 volts for a kilovolt. I think you could possibly see going up to 1,500. There are certainly components that exist that are maybe 1,200. There are definitely regulations that top out at 1,000, 1,500. But I think in the most part, I think it's unlikely we're going to see that certainly anytime soon. I think we'll be looking at mostly 800 and 900 volt architectures coming out from now on.
Yeah, I hope so, because the benefit of being able to charge very quickly is very appealing. And I think it's one of those things that people, of all the criticisms that I hear about EVs, and I hear loads, and I've been driving EVs for like 7-8 years now, so I've heard it all multiple times.
I think the charging problem is increasingly, in my opinion, becoming a problem for the off-vehicle stuff than it is for the on-vehicle stuff. So we're already seeing now problems where it's not the battery chemistry that's limiting the charge time, it's the fact that we only have 350 kilowatt chargers.
Yeah. Okay.
So yeah, that's the stuff that's now starting to limit the charging speed. Like chemistry, battery technology, cooling systems are all moving forward to enable 15-minute 10 to 80 charge times. But I think I'd also say on charging, it's very, very rare you're going to need to do a charge like that. Most of your charging is going to be done at home at 7 kilowatts. Like people get really hung up on how quick can I charge it from 10 to 80%, but it's fundamentally not that important in how you're actually going to behave with an EV. Yeah, it's like if you could fill up your combustion car at home, you'd never worry about how long it took to fill it up at a petrol station.
Yeah. It's funny because the number of conversations I had with people over the years about this, and I drove EVs when people wished me good luck when they told them that it just has a battery, because they just couldn't believe that I'm mad enough to drive one. But it's even if you explain that to people, they don't get it until they actually try it themselves, and it's that magical barrier. But I hope that young people are a bit more exposed to that idea and kind of will get there from the start. So going back to this cells and chemistry, who are you getting the cells from, or do you have your own providers, or do you work with whoever your customer is on that?
Yeah, I mean, we can't share exactly who the cell suppliers are, but we buy cells in a 2170 format from there's lots of companies that make them in Europe and in Asia as well. Obviously, the closer the cell factory is to the pack factory, the better. And we're always working on that. We're always working on looking at new technologies. The benefit of using the 2170 platform as well is when new chemistries and new technologies are available, really easy for us to swap them in, as long as they're in that 2170 format.
Okay.
So yeah, there are a lot of companies that do it, and we're working with a few of them.
Okay. But presumably, once you're providing a pack to somebody, you do expose that information to them, because or
oh yeah, I mean, there's no reason to sort of hide anything from customers. Customers know who the cells are coming from.
Well, I'm sure we can. People who I do have some listeners who work for big OEMs. They know. They'll tell me. I'll get emails. But just to reiterate, you're not looking to get a phone call from, I don't know, VW CEO tomorrow, or Stellantis. You're more towards, like, I don't know, what would be a British brand that is actually still in Britain, manufactured in Britain. I don't know. Land Rover is obviously too big as well, but like something even smaller that just produces a bunch of vans, for instance, or.
Well, I mean, there's obviously companies like Aston Martin, Bentley, Rolls-Royce, Alexander Dennis, who make the most double-decker buses on the planet. LEVC, who make the London taxi. There's obviously Lotus as well. JLR still make a lot of vehicles in the UK, as do Stellantis and Ford, and Mini is obviously still made in the UK as well. So there's still a lot of vehicles made here. Although I would like to see that number increase. It's trending downwards at the moment. I'd like to see it start trending upwards
same.
Again. But I don't know. I mean, if one of the sort of big groups were to call us tomorrow and say, we want to trial your technology, I'm open to looking at that. I think there are certainly benefits to it. I think with EVs, because the battery pack is sort of such a large component, I think having flexibility over it across different models and different vehicle ranges would really be a big value add, instead of having this common platform where it's just every vehicle is essentially the same. It's like, why would you buy an Audi Q4 over a VW ID3?
Yeah.
or vice versa. Why would you buy an ID3 over a Q4? Because they're identical underneath, literally identical. It's not like in the previous platforms where an A3 was basically a Golf. Now these two cars are the same. So I think there is value add in our technology to the larger brands, that we could differentiate those products using our technology for an amount of money that would still make sense to them. I think one of the problems they face is they do this platform thing because they invest billions of euros into a platform and then have to commit to it across every product it can possibly fit in to make the economics of it work. Whereas for us, we can customize your battery pack for a lot less, orders of magnitude less.
How do I put this? So when an OEM works on a big OEM, like you mentioned, VW and Audi and a group, when they work on the platform, they obviously, it's not just the battery pack. It's it's the whole lot. It's the charging infrastructure. It's the safety infrastructure. How it talks to the rest of the car. And it's obviously the powertrain as well. How are you with with marrying your battery pack technology with different power delivery systems? I should just call it like that.
Our technology is completely agnostic to the motor and the rest of the
so you
can work with any OEM on any architecture and run that vehicle integration engineering piece with them to make sure everything works.
Okay, and presumably long because I don't know about car OEM sort of world, but I know in the other tech worlds, when you work with a supplier, you kind of you always look at the contingencies and kind of safety of the whole thing. So in case your supplier goes belly up, or they change the tactic or whatever, you want to have the security of being able to support the platform long term. And I'm sure you've been asked all these tricky business questions in the past, but do you have anything you want to say to that?
I think on supply chain security, I think firstly it's a symbiotic relationship, right? It's like, you've given this example here where the OEM is worried about one of their suppliers disappearing. But equally, the supplier can worry about the OEM disappearing. And there sort of has to be that mutual trust there. There's going to be contracts in place to make sure both of you are sticking around indefinitely and de-risking that piece of delivery. But we really work with our customers, and we see that we're the more secure option in general. We make our packs in the UK, so there's no oceans between the car factories and the pack factory, or there won't be when the main factory opens. So there's sort of benefits there, and there's a lot of other security benefits. We see our customers more as partners than customers. We're working with them on really long-term projects, right? If we start working with a customer today, let's say it takes 1, 2, 3 years to get the vehicle into production, depending on a variety of factors. And then let's say the vehicle's in production or that model is in production for 5 years. That's an 8-year relationship. It's a really long time. So you've got to be really happy with what you're both doing. If you do a facelift version of the vehicle, right? If you do an upgrade, then it's 10 years.
Yeah. And I think one of the reasons why OEMs have kind of, some of them resisted and others struggled to grasp the EVs or the future of EVs, or their future, as a manufacturer of EVs, is the fact that EVs last longer as well in general, as a kind of in opposition to what everybody's been saying, that you're going to have to throw out your battery after 3 years. We've seen cars that have been 10 plus years on the road, and I'm on my second EV at the moment, and I've had it for 3 years now, and it just still feels like a brand new car, like the way it drives. Whereas in the past, when I had ICE cars, after 3 years, you notice that things were going wrong, and you had to change, I don't know, spark plugs or whatever. But the car just didn't feel like it used to. So, like I say, you have to have that relationship. So going back to the sort of the potentially tricky OEM questions that I may or may not have actually gotten from somebody who works for a big OEM. I'm not going to say who, but he knows who he is. Do you offer on? I haven't seen any on your website, but I presume you offer some sort of structural analysis of the pack. So quite often you see these videos. Just for the listeners, you see these videos online where people crash test vehicles, but a lot of that is actually done on the computer these days. Like nobody crashes hundreds of cars just to prove a point. You simulate all that. So and nowadays, obviously, battery pack becomes a part of that. So do you have any data so far of your battery packs on any technology demonstrators, which would be my next question. But sorry, this is a very long question, a very packed question. But feel free to answer as long as you want to.
Yeah. So the sort of structural component is very much part of what we see as the vehicle integration piece. So we take our platform and we customize it for what you need, and then we take the output of that, and we say, right, how do we now integrate that into your vehicle? So that'll be a case of, where are the bolts to connect it all together? Are you intending the pack to be a structural component of the vehicle? Because it's not always the case. If you are, what are the different sort of load cases you're expecting? What are the different vibrational cases? So there's lots to do in that vehicle integration piece, and obviously making sure the pack is structurally safe. And obviously there's regulations we have to pass for that as well. Like there's crash tests in Regulation 100, which is the sort of standard battery safety regulation. You've got to get through all these things to make sure the pack meets every tick box it needs to meet, both from a government and regulatory perspective, from our own quality standards, and from what the OEM wants to achieve.
Okay, but presumably, I mean, OEM will have that, big OEM will have that infrastructure in place. But if you're talking to somebody who's just a smaller size manufacturer, and there are some manufacturers that sell their cars or the vehicles sort of under the threshold of it being a car. So it just works out cheaper that way. And I don't know how that impacts the crash tests and all that, and and then you have somebody who makes 50 bin lorries. I'm sure they're not, I don't know for certain, but I'm sure they're not going to crash test 5 of them just to prove that they're safe.
Yeah. I mean, you still have to get through a certain level of safety regulation on that, irrespective of how many vehicles you make. But from a battery pack perspective, we'd never ship a pack we didn't think was safe,
of course,
irrespective of whether someone wanted to fully homologate the vehicle or whether they wanted to put it through individual vehicle assessment, which is basically what you were sort of saying there, where you build sort of really low volume and you get the vehicle certification agency of whatever country you live in to come and say, yeah, that one is safe. And every time you build a car, you do that. Even if the customer was doing that, we wouldn't do that on the pack side. And also because of this shared platform, we know that there is inherent safety built into how we're designing every single battery pack because we've tested the platform.
Okay. To that end, do you have any technology demonstrators that you can show, or that or other in development? Because obviously, like going to your website, one of the first things that I wanted to see is like, do you have anything that I can see that drives, basically?
Yeah. So sadly, we can't talk about customers because NDAs are sadly but yeah, we have real battery packs, modules. You can come to our lab in London and pick them up, and see them, feel them. They really exist. We just can't share them online, unfortunately.
Okay, I'm not going to invite the whole listenership, but I might take you up on that offer. So you've only started, you're pretty young. You've only started last year, right?
Yeah, January 2022.
Now, here's a tricky question. What is your runway currently? Like, because obviously, I'm sure you're looking for people to invest money, and what is the business end of things looking that way?
Yeah, I mean, I suppose if there's anyone listening who really loves this idea and wants to invest, then obviously feel free to let me know. But like runway wise, it's not an issue. Yeah, there's lots of different opportunities, lots of different customers, lots of different grants available. Commercially, I think there's a lot of opportunities in the UK in
Okay,
this space.
that's good to hear, because we've been kind of dominated, especially when it comes to EVs, with Chinese manufacturers, and I don't have anything against them in general, but I just don't like the fact that we might be reliant on one country providing all the technologies in the future. It's not the future that was good for anybody.
Well, I think technologically the UK is a leader.
Okay.
In manufacturing, it's certainly decreased over the last 50 years, unfortunately, and we're part of the effort to try and get that on the upwards trajectory again. To bring manufacturing back to the UK. But technologically, the UK is certainly a leader on all fronts. Like ARM is a British company, and they're one of the leaders in chip design. There's obviously lots of great battery companies with lots of interesting technology. So I think on the tech side, the UK is certainly up there with any other country.
Okay. Yeah. That's good to hear. I mean, I keep on hearing about all these startups doing battery technologies. I haven't visited a single one yet, because most of them I've heard about over the lockdown periods, and obviously wasn't the best time to travel around, and people were working from home a lot, so I wouldn't be able to visit anybody. You mentioned that manufacturing, you're going to do the manufacturing in Britain, but obviously sometimes you have to serve markets like US or some Asian markets where they actually have a requirement to have the manufacturing in a different country. Do you ever see customers from other kind of countries, or are you just focusing currently on British and European?
I mean, I'd say we're certainly focused on European, but that doesn't stop us from ending up having conversations with Asian and American customers. I think we would expect you need quite a significant. You need to be a larger, low volume customer to justify sort of having your own factory.
Yeah.
To open a factory in a certain geography just because you were our customer. It's certainly something we're open to if it comes up. But in general, we plan to ship globally from factories in the UK. With obviously exceptions where it makes sense. If it makes sense to open a factory in the US, then we'll do that, and the same for India or Asia generally.
But you don't have any plans at the moment, obviously. That's what you're saying.
Not right now, right? I mean, we're a year old. Right?
Yeah.
We need to make sure we walk before we run.
Yeah, that's true. I'm just just trying to see what sort of plans do you have, because some companies do have the investment in place that actually kind of hinges on them having the ability to actually scale in the future. Some don't. I personally think it's better to do slow ramp up, and from all the businesses that I've ever been involved in, the ones that failed are the ones that had loads of money coming from everywhere, and they just had to spend.
Yeah, I think you need to grow sustainably. Even if I personally had a pot of £1 billion to attack this problem, that wouldn't mean that I'd go and open a factory in every continent on Earth.
Yeah. I'm not. Yeah, I don't have £1 billion to invest, but if I had, I would agree with that. So you mentioned the structural. That obviously the battery pack is a structural part of the car. What do you think about the manufacturers like Tesla, and I'm sure others are going to try this as well, is to kind of build in the battery pack into the chassis of the car, so it's not removable essentially, or very hard to remove. obviously,
I think it's one of those. I think it's one of those things that probably makes sense economically, but probably doesn't make sense environmentally. Um, I think we're obviously seeing now that the new Tesla pack, the 4680, is just essentially one big tub of adhesive that's then glued in as a critical component of the vehicle. Which essentially means if you have a fault in the battery pack, there's no point even trying to fix it. You may as well just get a new car. And I think that's where those kind of approaches are going. Is when you have a fault like that, they're just going to give you a new car. For us, we don't take that approach. I mean, we try and make our modules really, really big, so that sort of approaches that cell to pack approach, where the whole goal is to reduce the amount of structural weight to increase the overall energy density. We're certainly taking that approach by maximizing the size of our modules, but we don't go the step further and just fill the pack full of adhesive, because we do want to be able to service it. We do want to be able to minimize waste on the first life, if possible.
Yeah.
So maybe economically it makes sense, but it's not something in a hyper high volume environment. But in low volume, we don't think it makes tons of sense.
Yeah. I mean, obviously, you're providing battery packs to manufacturers. So I just wanted to hear what your opinion on that is, and I have to agree that the seeing how people used to salvage the Model S, it used to be in a day, modules from those cars and kind of reuse them for all sorts of things. I think that was very beneficial and kind of provided a second life to battery packs. And I've seen in person the Model 3 battery pack, or the bit of it, and like I say, it's just a gloop of glue. It's not, I'm sure it can be recycled somehow and recovered somehow, but it's not. I personally do not support that approach. I think, to me, that's just a bit of a wasteful cost cutting. But I'm just worried with all these Model 3s on the road. What's going to happen to them?
I mean, I think they will all be recycled.
Yeah. Okay.
I mean, it's legally obligated now, at least in the EU.
Okay.
You have to recycle the battery pack.
Okay.
So it will be. It's just not one of those. It'll just be one of those things that happens at the end of the vehicle life, as opposed to a serviceability thing.
Yeah. Okay. Do you ever see providing battery packs for other solutions, like, I mean, completely, different cell chemistry, but like an opposite example of car would be a home storage, or a grid storage, or grid level storage. Do you ever see yourself doing that, or you're kind of just focusing on OEMs?
Yeah, no, we certainly see opportunities in other sort of verticals, right? Looking into grid storage or looking into other transportation. I think our core focus for right now is automotive, but we will definitely be looking at. Well, we'll certainly be looking at grid storage in the future.
Okay. Yeah, that's good, because I think that's where that's the sort of other avenue that is underserved. That's the word I was looking for. And I think there's a big big market out there. So just going back to you and your company, obviously you mentioned something called ARC on your website. Can you run us through? Obviously most people who are going to listen to this they're just interested in this, and they might hear about it, and and might be might be excited about the future, that you guys are kind of helping develop. But run us through the sort of what does the battery pack development look like, and how do you help? Like, obviously it's more than just taking the cells, gluing them together, and in some of them parallel, some of them in a string, and chopping on a BMS and then a cooling system around it and putting in a cage. Can you just run us through that process?
Yeah, so ARC is our battery platform. So ARC has software and hardware components. So in software, we've created software tools that allow us to automatically design battery packs, sort of as I alluded to earlier. And the hardware side, what we've done is we've set a load of constraints on the platform. So we've said we're going to use this material, we're going to use this adhesive, we're going to use this manufacturing process and this geometry, and build that across the whole platform. And what that allows us to do is it allows us to get through the design phase really quickly. So instead of spending a year going, which material are we going to use or which manufacturing process are we going to use, working out how many series in parallel we should use, we can do all that pretty much instantly.
Okay.
So we can now get through design phase really fast. And then we can go into, then we do the vehicle integration piece in the design, so making sure the pack works with the vehicle really, really well. Then we can go into the testing phase. So we're now certifying that this new battery pack is safe and meets all of the standards for homologation. And we can get through that way quicker because we're using our platform. So a lot of the platform has gone through a lot of the tests already. So instead of having to do 50 tests, we have to do 10.
Okay.
So we can reduce the amount of testing you need to do. And then you take that into manufacturing, where you have this really flexible manufacturing line for the platform and not for a product. So you can, as I said, send down the pack for a car and then the pack for a bus and then the pack for an SUV down the same manufacturing line sequentially to make that process really a lot more efficient. But there are obviously sort of a whole host of steps that sit underneath that, right? Like, we will have originally had to choose what welding technique to use and what materials and what processes and what adhesives, and then you've got to go through your design validation plan, DFMEA and PFMEA, and there's you've got to do cell selection at the start, right? I mean, we still have to do cell selection to an extent and justify which cell we're using and why. Looking at degradation, looking at beginning of life performance. So there's lots of different things that sit underneath this. Wiring harness, control system, electrical design, connecting all the modules together in whatever configuration makes the most sense for the vehicle. So there's still a lot of design that has to go through, even once you've built this platform. But this platform really is a big head start versus everybody else. You're saving a lot of time and money by having the platform.
Okay. But the cost saving is that basically you've integrated it all and you're able to manufacture it quite flexibly. So if somebody has to change, I don't know, the type of adhesive that I want to use for whatever reason, you have a bunch of them tested, presumably, or
Yeah, we just know which one's the best. We've just chosen one.
Okay, fair enough.
So you don't even have to worry about it. We just sort it for you.
Well, same with like welding, presumably. I mean, it's funny once you get to when you design anything. Once you get to actually doing it, there's all these details that you never thought about that you come across, and like I would never think about what welding do you have to use for a battery pack. But
lots of different methods.
What about the things like the BMS? Because I have a feeling that some OEMs choose or design their cars very conservatively, and they want them to last longer, whereas others want them to charge very quickly, but they know that the battery pack's going to, the state of health is going to drop down to, let's say, 75% or 80% after a couple of years, and it's kind of built into the process. Do you have that kind of built into your processes as well?
Yeah. So every pack ships with a BMS, with a custom application layer. So custom control system for exactly what that pack needs to achieve. And you're right. Some car companies want really conservative. Say they're only using 90% of the available energy. Some want to push the limit. Some want the fastest charging, the most use of the available energy, and all those different things. So we can cater to all of that depending on what you need to achieve.
Okay, that's good. It's good to hear. But I presume there's more than one BMS to choose from, because that's where all the complexity of the battery pack design kind of meets and has to be controlled, right?
Yeah, I think the software is what's most important on the BMS. It can make tens of % of difference to performance.
Okay. So, what are the sort of the most tricky questions you've heard from people being asked about battery packs that I didn't? I presume I asked one or two, but yeah.
Yeah. I think the ones that, not necessarily the most tricky, but the ones that I get asked most regularly are things that I put in the category of like EV myths.
Okay.
things like they're worse for the environment. Things like there's 15 different charger types. And I get asked that by my family, I get asked that by friends, I get asked that by people I meet. And so those are always the ones that they're not challenging, but it's just like you got to go through them a lot. You got to explain that no, in fact, EVs are better for the environment, and pretty much everybody agrees it.
And they're more fun to drive as well. Like, come on.
Yeah, and you get instant torque demand
Exactly.
at all points of the RPM. So why would you not want that?
Yeah. I said that story many times over, but I used to have a Insignia. It was a diesel engine, and I could on the motorway I could reduce, at 70 something miles an hour, I could reduce from the 6th to the 5th gear and spin the tires and get smoke out of the back. And then I drove into Nissan dealership one day, and I test drove a Nissan Leaf 30 km/h, which you would think it's not the fastest car, but I took it off the eco mode, and I was blown away by the speed and the silence of it. And I just basically traded in my Insignia and got myself a Nissan Leaf, which was my first EV back in 2016. And people were like, "Why would you do that? That's crazy." But it was just one of those things. Like you mentioned, the charging at home. It's something you can't just explain to people. They have to kind of get over that hump in their head and try it themselves. You're very efficient at answering questions, which I like. Yeah, I mean, it's a sign of a good communicator and good CEO. Like, somebody who can get to the point. But what do you drive yourself? What is your current choice? Presumably, you have an EV. Don't tell me you don't have an EV.
Well, so I live in London at the moment, which means basically there's no point me having a car.
Okay.
So I actually, well, I won't name the service, but I use car sharing a lot. So I'd like there's cars parked everywhere in London, and you can just pick them up and drive them to another place in London. And obviously, the public transport network here is really good. But yeah, I'm probably going to be buying a car quite soon. And yeah, obviously, it will be EV. But other than that, when I'm at my family home, we have a Golf, which is quite standard.
That's a very reliable, car. So
yeah, I feel like it's the most average car, if that makes sense.
Yeah.
It's like it just is what I think a car sort of should be. There's no like crazy extremes.
It's one of those cars that's kind of good enough. Basically, it's just like provides, And oddly enough, actually, Leaf had about the same amount of space, and it was supposed to be that kind of car. So, would you ever?
Yeah, I'll be getting an EV soon, probably.
Do you know what kind of EV you're going to get, or?
I'm looking at a few different ones. I think obviously, Tesla Model 3 is an obvious option. I quite like the Polestars. They look quite good. I think Kia / Hyundai, that group, they're doing some really good stuff in the EV transition. The Ioniq 5 and the EV6 have some cool tech in them. So I think I think I'm going to have to go test drive them all. Basically, is what's going to.
I can recommend GridServe if you want to have a do a road trip somewhere. There used to be a place in Milton Keynes called EV Experience Center where you could just test drive, but they ceased to exist. They were very good. But a GridServe is one of those places where you can just show up and if they have EVs, they'll let you test drive them.
Cool.
Would you be ever obviously with like technology demonstrations and all that, but would you ever be tempted to have your own car that you have your own battery pack on, or would that be too extreme?
Oh no, I mean I'm definitely looking forward to driving a car with our battery pack in it.
That's a good answer. But since you mentioned that most like giant OEMs are probably not going to be sourcing the battery packs from you, obviously you would have to look at something niche. But
but there are a lot of fun niche vehicles, right?
Yes, exactly.
James Bond drives a niche vehicle.
True. Like it's those sort of cars that I never think about, like McLaren or like all these sort of British brands that are niche. You're right. I mean, I hear about them all the time. So to me, they don't sound niche. If that makes sense.
Yeah.
But I suppose if you look at the volumes that they sell, it's not too bad. Anything else that I should have mentioned, or
No, I don't think.
if anybody has any questions, obviously they should visit your website.
Yeah. Follow the company. Add me on LinkedIn. All those usual things. Follow us, and I guess if anyone's listening who needs battery packs, do let me know.
Yeah, I'm sure there's going to be one or two people. I hope there's going to be one or two people. Like I said, I do have some listeners who convert EVs or just work for companies that are, at least they follow me on Twitter and ask, and I've interacted with them in the past at meetups. So they're out there. They're out there. Anyway, thank you for your time, James, and it was fun talking to you.
Yeah, great speaking to you too. Thanks.
Thanks for listening. Hopefully you've enjoyed this content. As always, you can reach me out on emails, takeitev@gmail.com, at takeitev at mastodon.social, and if you're still using Twitter, it's at takeitev, obviously. If you're interested in the subject, or you actually are interested in the services that James offers, to let him know that you came from here, and I'll see you out there on the next one. Thanks very much. Bye.